Yeah, it's good to be back. Nowadays, virtual private network becomes more and more prevalent. For enterprise, SSL VPN is the most convenient way for their employee to connect the corporation network. For hackers, it's also the shortest path to compromise your intranet. So today, let's take a look at how your SSL VPN could be wrong. Oh, before that, is there any NSA here? Okay, sorry for the title. Hi, I'm Orange. We are from DevCore research team in Taiwan. I'm now a zero-day researcher and focusing on web and application security. Apart from that, I'm also a speaker, CTF player, and a bug bounty hunter.
Hello everyone, I'm Mei Zhang. I'm a security researcher from DevCore, and I play CTF in HitCon and 217 CTF team. I mainly focus on binary exploitation.
Here is the highlights today. We will disclose pre-auth remote code execution on both Fortinet and ProSecure SSL VPN. In the Fortinet case, we will show you the hardcore but reliable binary exploitation with a magic string to open the door. In the ProSecure, we will present the out-of-box web hacking and how we bypass the two-factor authentication on Twitter and hack into their most important server. Last but not least, we will introduce how we leverage a hidden feature to take over not only your SSL VPN, but also all of your clients. And this is the agenda. We first introduce the SSL VPN and why we focus on that. Most of the SSL VPN don't provide a shell. We will elaborate how we jailbreak the appliance and introduce the attack vectors to discover bugs. Of course, we will have case studies and demonstration. And the last is the SSL VPN weaponization and recommendations. So, what is SSL VPN? Compared to the site-to-site VPN such as the IPsec or PPTP, SSL VPN is more ease of use and compatible with any network environments. All you need is just a browser. Because of the convenience, SSL VPN becomes the most popular remote access way for enterprise. SSL VPN are everywhere and protect the corporation access from internet exposure. They are trusted to be secure and considered as the only way to your private network. But what if your trusted SSL VPN are insecure? They will become your virtual public network. Yes, public. So that's why we focus on SSL VPN. They are important, but a blind spot. They are widely used by corporations of all sizes, but only few vendors dominate the market. According to our survey on Fortune 500, the top 3 SSL VPN vendors dominate about 75% market share. So if you find a high-impact vulnerability on one of the leading SSL VPN, you can hack the planet. The most important is SSL VPN must be exposed to outside, so it must have direct intranet access. Due to its importance, even NSA is hunting for SSL VPN bugs, such as the encryption group leaks. SSL VPN is trusted by large corporations, industry leaders, and tech giants, such as the Facebook, Twitter, and Marvel. Yeah, the logo is very cool. Even the NSA use the SSL VPN. They are everywhere, but usually forgotten. Sometimes even hacker knows your SSL VPN more. For example, we disclosed a pre-auth remote code execution on Palo Alto SSL VPN 1 month ago. We find a bug accidentally. However, while reproducing on the latest version, we failed. So we start to doubt if this is a known vulnerability. We searched all over the internet, but could not find anything related. There is no CVE, advisory, or any official announcement. Therefore, we believe this is a silent fix one day. We surveyed all over the world and find Uber suffered from this. So we reported their bug bounty program. This is not a fault on Uber. They are also the victim. We also report this to the Palo Alto PCERT, but we got the following reply. They do not CVE items find internally. So that's the reason why there is no official advisory. Okay, this is fine. There is no CVE, so there is no vulnerability. Anyway, Palo Alto still assigned a CVE for that, just right after we published all the story. Once we decide to research into SSL VPN, the next question is how to choose the targets. We did a little survey on leading SSL VPN. As you can see, even in the high severity level CVE, the Pro-Secure and Fortinet are still the most secure one. We want to challenge the mission impossible, so we put our priority on Pro-Secure and Fortinet more. Pro-Secure is the most famous VPN solution in the world and has the least high-level CVE. It's trusted by large corporations, service providers, and government departments. Fortinet is more used by end users and medium-sized enterprise. It's common in Asia and Europe. Both vendors have little high-level CVEs, so our mission is to find the pre-auth remote code execution on them. So let's start hacking. To kickstart new research is always not easy. SSL VPN is a black box enclosing source appliance. They usually build their own architecture stack from scratch and don't provide a shell to dive into. So the jailbreak is the essential step for researchers to turn the black box into the gray box. As you can see, most of the SSL VPN only provide a restricted shell. So let's talk about how to jailbreak them. We are not the hardware guys, so we start researching from the virtual appliance. All the virtual appliances can be classified into the typical one and the encrypted one. It's trivial for typical one, so we don't pay a lot of time here. You can just enter the single user mode or mount the virtual disk on your box to modify the file system to get a shell. But what if the disk has been encrypted? Without the booting process, we cannot see anything. So today, we will show you a trick to bypass the encryption. Here is the Linux booting process. The common way in past to break the encryption is to analyze or reverse the VM Linux kernel to get the encryption key. However, we focus on another stage. Here we give an example to show how memory forensics takes us to the win. As we know the booting process, it starts from the BIOS, bootloader, and the kernel to drop the first process to initialize the operating system. In Pro-Secure, the initial process shows you a prompt. Press Enter to view or update your appliance settings. And once we press the Enter, the initial process spawned another process to allow you modify and view the settings. So we suspend the virtual machine at this time and scan the entire memory to do the memory forensics on the host OS. From the memory forensics, we observed that the spawned process is a Perl script. The name is dsconfig.pl. And since it can be the weak point of whole the booting process, so it's time to show the magic. We will just patch a few bytes to pop out the shell. We patch the memory and replace the dsconfig.pl to the bin sh. Once the modification is done, the only thing we need is just press the enter. And we got a shell. Now, thank you. So now we have the full control of the system and can do further debugging and analyzing.
Okay, so now we can start hacking SSL VPNs. But where's the bug? There are many daemons running on the server. They're usually complicated and hard to analyze. Digging at the correct place is important for us. So we propose some attack vectors specific for SSL VPNs. We'll talk about a special feature called web VPN. It's powerful, but also vulnerable sometimes. We got lots of bounty from this feature. It's like our slot machine. The next one is the native script language extensions on SSL VPNs and how they can be dangerous. And we'll also introduce some multi-layered architecture problems. Web VPN is a convenient proxy feature. It's portable and clientless. It proxies all kinds of traffic through the web browser. It supports various protocols like HTTP, FTP, and RDP. It also handles many web resources, such as WebSocket, JavaScript, and Flash. We don't need to install any software. Only click on the browser, and we can connect to all the services. Sounds powerful, right? Apparently, it's not easy to implement this feature. Some vendors choose to implement by themselves. However, protocols and web resources handling are prone to memory bugs. Think about SSL VPN processing SMB or Flash. You know how hard it could be. Also, this requires high security awareness. For example, we found some debug functions and sensitive data without encryption and information exposed carelessly. Some vendors decided not to reinvent the wheel. They modified from an open source project directly. But they copy the code and also copy the bugs. This kind of software are hard to maintain, update, or patch. Or some vendors choose to call existing libraries, but the vendors are often neglect to update these libraries. We found libcurl and libxml from over 10 years ago. Implementing web VPN is really not easy. This is the most serious attack vector we found under SSL VPNs. During our research, we found that most SSL VPNs have their own native script language extensions, like PHP extensions written in C or Perl extensions written in C++. Vendors like to use these extensions to do encoding, decoding, or other operations to improve efficiency, which may be vulnerable. And it's really prone to type confusion between different languages. As we know, string operation is always difficult for C, like buffer size calculation, dangerous functions such as string copy, or misunderstood functions. For example, do you really know how the return value of smprintf should be? Can it exceed the buffer size? Actually, it's possible. So calculation like this will cause an integer overflow. The type of these extensions are also confusing. Although they seem the same, but do you really know what type it is? Do you know if you are using it safely? Who knows? And this may cause serious problems. The last one is the multi-layered architecture problems. When there are different standards for processing the same thing, the inconsistency between them will lead to problems, such as the attack surface on reverse proxy and Java Web Backend, the talk from Orange in DEF CON last year. And here we gave another case. This is also an access control bypass. It's on C web server and RESTful backend. The regular expression .plus matches too much, so we can leverage this to match the // to access the privileged pages. Okay, so here is the special attack vectors we found on the SSL VPNs. Following, we're going to talk about 2 case studies. We will show how we get the pre-auth remote code execution on FortiGate and PostSecure. Here is a disclaimer. All the CVEs mentioned below have been reported and patched by Fortinet, PostSecure, and Twitter. So please go update your SSL VPNs as soon as possible. The case 1 is FortiGate. We first jailbreak the FortiGate and look into the binaries. We try to list the binaries in /bin, and we found they are all symbolic links, point to /bin/init, just like this snapshot. FortiGate compiles all the programs and configurations into one single binary. This makes the init program really huge and annoying. The IDB file of init is up to 500 megabytes with 85,000 functions, and they are all stripped, no symbol. It contains plenty of function tables to manage each program, including the web daemon. Through our investigation, we found the web service is modified from a patch, but it's a patch from 2002. So the web server running on your SSL VPN is actually as old as your grandmother. Compared to the admin page, the user login interface is the only one that's definitely exposed to the internet. It looks like this, a simple login page, no other buttons or functions. So we're gonna explore through this interface without authentication. We will talk about 3 bugs today. First is the pre-auth remote code execution chain. We combine 2 bugs: a pre-auth arbitrary file reading to log in, and a post-auth heap overflow to get a shell. We also introduced an interesting bug, the magic backdoor, which can modify any user's password with a magic key. Let's start with the file reading part. It was a function used to show corresponding language for users. It concatenates strings directly without a // filter, but a JSON extension appended automatically. So it seems like we can only read JSON files. Think about it. Can we remove the JSON and read any file we want? The answer is yes. We can utilize the feature of smprintf. According to the main page, it writes at most size -1. The buffer size is fixed here, so we only need to make it exceed the buffer size, like this. We fill it up with slashes. So the path after smprintf becomes like this. The appended JSON exceeds the buffer size and is stripped by the smprintf. Then we can read however we want. After getting arbitrary file reading, we found something interesting. We call it an SSL VPN mystery. It appears in many products, not only FortiGate, but PostSecure or other vendors. The mystery is they hold an excessively detailed session file on the SSL VPN. The file is called SSL VPN web session. What's the content? Session token, of course. IP address, sure. Username, indeed. Plaintext password. Are you kidding? Yeah. You should never store any plaintext password. We really wonder how this became popular. Let me guess. Maybe they learned it from Google or Facebook or Twitter. Who knows? Just kidding. Anyway, these plaintext passwords are really convenient. We don't need to crack password anymore, and we can log in easily. Today, we're going to utilize the web VPN feature. As you can see, it supports many protocols. Let's try the HTTP. We only need to type the URL, and we can connect to the website through a VPN. And we look at the URL. We can see that we're still connecting to the SSL VPN. So it proxies the whole website for us. And if we look into the elements, we can find the URL of resources are also from SSL VPN. It rewrites all the URLs for us. As you can imagine, this involves in heavy string operation. So here is a heap overflow. It occurs in JavaScript parsing, and it's simply because lack of length check while memory copy. The buffer is only 0x2000, but the input string is unlimited. Generally, we do some heap function to overflow a nice target and control the program counter and do code execution. But the situation is difficult in FortiGate. We face something destabilizing. First of all, the web daemon handles connections with ePOL, so it's a single-thread process. And the main process and libraries use the same heap. It means all the memory allocations of all the operations in all the connections are the same heap. So the heap is really unstable. Moreover, there are some operations regularly triggered. They interfere the heap arrangement and is uncontrollable. Therefore, we cannot arrange the heap allocation carefully. That would just make a mess. And there is something even more ironic. Apache implements an additional memory management, so there's no free until the connection ends. We cannot arrange the heap in a single connection. The allocator also limits our exploit. It's called JE-malloc. It centralizes small objects. It calls a block of allocated memory a region and then maintains these regions in a ROM with a bitmap. This effectively reduces the interference between small and large objects. It also limits our target options. It's hard to put small objects nearby our buffer. So we're stuck at that time, and therefore we started to fuzz the server, and it crashed. And we almost control the program counter. And yet, this is why we love fuzzing. We crashed a function table pointer in an SSL structure. This structure stores information of each connection. It's used for connection handling, and is an ideal target for our heap exploit. First, every new connection allocates an SSL structure, so we can trigger it easily. And its size is close to our JavaScript buffer, and therefore it can be placed nearby our buffer with a regular offset. The most important is it has some useful structure members. It contains a function table pointer called method, and this is how we triggered the crash. But we found one even better. It's a function pointer called handshake function. With this, the exploit can be much easier. We don't need a whole function table anymore. We only need a function address. All the connections are on the same heap, so we can mess up connections and overflow the SSL structure. So we send lots of normal requests and attack the server with an overflow request in the meantime. If we look into the heap, there may be several SSL structures on the heap. For example, here are 3 SSL structures for 3 connections. And the SSL structure is like this. Some basic information and the function table. And the function pointer is now pointing to an SSL function, SSL accept. Now if we trigger the JavaScript parsing, and the JavaScript buffer is allocated ahead of these SSL structures, then we can trigger the overflow and override the SSL structure members like this. So now we fill up the SSL structure with capital A's and make the program crashes. What we need to do next is clear. We only need to forge the SSL structure with a fake function pointer, like the address of system. So when the victim connection is trying to do handshake, the program executes whatever we want. Anyway, the heap is unstable, so we need to send fuzzy connections to meet the condition. The server may crash sometimes, but it's fine. FortiGate has a reliable watchdog. We just need several attempts, taking about 1 to 2 minutes to get a shell. So this is the whole details of how we achieve remote code execution. Maybe some of you are not binary guys, so you may wonder, is there any other way to get into the server? So why not find another door to make your life easier? We found a magic backdoor in the login page. This function was originally used to update outdated password. However, they failed to authenticate. So we can simply use this secret key, which is called magic, to reset any user's password. Now we're going to demonstrate how we pop a root shell from the only exposed HTTP export. We put our PHP exploit on an HTTP server, and this is our exploit. In order to control the parameter of system, we first do a stack pivot and make our buffer become the stack. After that, we do an RP chain to call system. And here is the reverse shell command. We use Python to build a reverse shell. And we concatenate these strings to overflow the SSL structure. Now we can start hacking. In the first panel, we open a port to receive the reverse shell. And we start a fuzzing thread to build multiple normal connections. Then we attack the server. We first try to leak username and plaintext password from the web session. As you can see, we found a username, main, and password. This is password for main. We can use this account to log in and make the SSL VPN proxy our PHP exploit. We only need to wait a few seconds. Okay, here we got the root shell. Thank you very much.
Okay, the next case we talk about is PearlSecure. PearlSecure is the market leader of SSL VPN and was from a diverse teacher of Juniper networks. They are a Perl lover and built all the architecture stack from scratch. The architecture is old, but stable and secure. And it's worth to mention, PearlSecure hooks all the process by LD preload. Due to the monitor and security consideration. We will discuss this later. Here is the vulnerabilities we find. Among them, we will introduce the pre-auth arbitrary file reading and the post-auth command injection. We chain these two bugs into the pre-auth remote code execution. The first bug is the pre-auth file reading. PearlSecure introduced a new feature called HTML5 access since version 8.2. It can access the telnet, SSH, and remote desktop by browsers. In order to adapt the new feature, PearlSecure created a new if condition to handle all static resources. Thanks to the new feature, the original strict validation has been bypassed. So, another effect by this, all unpatched versions except the end-of-life version are affected. Here is the payload for you to check your SSL VPN. When there is a special path in the end of the URL, the path validation becomes loose. And what can we get from this? We can get numerous useful information, such as the server private key to decrypt the SSL connection. We can also get the important configurations, such as the radius and LDAP password. And all users' password hash and sensitive cookies, which are cached in the web VPN, like Google, Dropbox, and iCloud. The last and the most important is the cached plaintext password. Yes, plaintext again. For now, we get a credential, so we are able to access the corporation network easily. However, our goal is to get code execution for persistent and further actions. So here we chain a command injection in management interface together. From this code fragment, it's very obvious and straightforward. If we can control the options, we can inject arbitrary command to this Perl function. And of course we can. We can control the options from the troubleshooting page. So, is that simple? No, I don't think so. In order to avoid potential vulnerabilities, PearlSecure applied a lot of hardening on their products, such as the system integrity check and the read-only file system to protect the backdoor from backdoors in Chrome tab or webloot. The most effective hardening is the DSSF module. It's like the safeguard to protect Perl from dangerous operations. The DSSF is a Perl module which is written in C++. The module implements its own command parser and hooks several dangerous functions, such as the system, open, and backstick. It also disallows numerous bad characters and re-implement the Linux I/O redirection in Perl. So due to the hardening, we cannot perform any command injection. We tried several ways to bypass the hardening. Of course, the first come out of my mind is the argument injection. However, the TCP dump in PearlSecure is too old, so it failed because it didn't support several juicy features, such as the post-rotate command. While examining the system, we find PearlSecure stored a template cache in a directory. We try to write into this directory, but we can't use standard out because it's already directed to the null device. What we can do is only abusing the saved file argument. But it seems there is no way to generate a polyglot file in both Perl and pcapt format. So it's time to dig deeper. We dive into the DSSF implementation to see is there anything we can leverage. We found a flaw in the command parser. When there is an incomplete I/O redirection, the rest of the I/O part will be truncated. However, although we can recontrol the standard out, we still can't find any way to generate a valid Perl. So let's think out of the box. Standard out is uncontrollable, but could we write a script by standard error? When you force the TCP dump to open a non-existent file, it will show the error, no such file or directory. From the error, it seems we can partially control the message. we try to pipe the standard error to Perl, but we still get nothing. However, when we try to use another file name, such as the print123 with a hashtag, we try to pipe the standard error to Perl again, and the magic happens. The Perl print out the 123 without errors. So, okay, the Perl 101. Perl supports the goto label, so the TCP dump with a colon becomes a label in Perl. And we use the hashtag to comment the rest of the part. So the standard error becomes a valid Perl null. This is our final exploit. We will explain the payload one by one. The first is to make the TCP dump open a non-existent file. The file name will be part of the error message in standard error. And then we redirect the standard error into the cache directory. Here we name the file as setcookie.txt and error.ttc. The last is the incomplete IO symbol. This symbol abuses the command parser to ignore the rest of the IO redirection. Once our standard error has been written into the cache directory, we can just fetch the corresponding patch to execute our command. By training these two vulnerabilities, we can get a reliable pre-auth remote code execution. We have reported all of our findings to Perl Secure PCert, and this is the response from them. They fixed all the bugs within a month. Their reaction is very quick and professional. It's a great time to work with Perl Secure. They are such a really responsible vendor. After Perl Secure released all the patches, we kept monitoring the internet to see the large corporations' response time. Twitter is one of them. They are known for their bug bounty program and nice to hackers. However, it's not good to exploit a one day right after the patch released. So we wait 30 days for Twitter to upgrade their SSL VPN. This is the Twitter SSL VPN. It's just a simple login patch. From the reconnaissance, we know the last time Twitter upgrade is in last December. So Twitter is likely vulnerable. We have verified the bug and got a bunch of user credentials in plain text. However, we encountered some problems while trying to pop out a shell from Twitter. Yes, the first problem is the two-factor authentication. Due to the two-factor authentication, although we can get the plain text password, we still can't do anything. So the first thing we need is to find a way to bypass that. We observed Twitter enable the roaming session. Roaming session is a feature to enhance the mobility. It allows a session from multiple IP locations. So once we know that, we download the database and forge the session to bypass the two-factor authentication. And finally, we log into their instance. The next problem is the access control in management interface. As we mentioned before, we have a command injection here. However, for security consideration, most of the corporations disable this interface on public. So we need to find another way to access the interface. We leverage the web VPN feature again to connect to itself. It's just like the SSRF. We use the 0 to bypass the SSIF protection and access the management interface. And finally, we got there. However, the last problem is that we don't find any manager's plaintext password in cache. Practically, most of the managers only log into their instance at the first time. The only thing we have is the password hash inserted ND5 crypt and SHA-256 format. So, we launched a 70-core AWS to crack the hash. And 3 hours later, we cracked the hash and successfully logged into their management interface. We are lucky because the length of the password is only 10. And the first character is capital B. It's on a very early stage of our cracking queue. We exploit our command injection and try to run the command ifconfig. And we got a shell. We report all of our findings. Thank you. We report all of our findings to their bug bounty program and got the highest bounty from Twitter. Also, we cannot prove that. It seems this is the first remote code execution on Twitter. Okay, the last is the bonus for you. Our company, DevCore, provides the most professional rating service in Asia. So let's talk about how to make the rating more red. In a rating operation, the personal computer is more valuable. So in order to take control of all the clients, we need to weaponize the SSL VPN. There are several old-school methods before, such as the waterhole attack and repress the VPN installer. But here, we propose a new method. It's the logon script. Logon script is the feature in almost every SSL VPN. It can execute corresponding script to mount the network file system or change the routing table. So here we will show you a demo to show you that how we compromise all the VPN clients. Okay, this is our demonstration. As you can see, the exploit needs one argument, so we append our target right after the exploit. Here we got the username and hash of admin. Also, we could not find the plaintext password. We can still change our cookie to the session ID of admin. Okay, once our modification is done, we can access the management interface. And we have become the admin. Thank you. Here we leverage the feature on the user roles and the VPN tunneling. We find the logon script section. Here you can see the logon script supports not only Windows, but also Linux and Mac OS. So we use the calculator as our backdoor. And once our modification is done, we change to the laptop of our victim. Yeah, it's cute. The victim launched the PearlSecure agent and tried to connect to the SSL VPN with his username and password. And once the connection has been established, the calculator will be popped automatically. Okay, here we finish all of our slides. But how to mitigate such attacks? Here we give several recommendations. The first is the client-side certificate. Without the certificate, the malicious connection will be dropped during SSL negotiation. The next is to enable multi-factor authentication. It can decrease numerous attack surface. And the last, remember to enable full log audit and subscribe the vendor's advisory to keep your system updated. This is the end of our presentation, and here is our contact information. We will We will post all the detail right after our talks. So please check that and let us know if you have any further questions. Thank you for being here again. Thanks.